This is the Essentials of Geometry Day 1 lesson. For your warm-up was a review from Algebra, and you should have gotten the following answers. For number 1, you should have gotten x equals 9, 2x equals -1, 3x equals 1, 4x equals -6, 5x equals -1, and 6x equals 1. Points, lines, and planes. There are several definitions and pictures to go along with the definitions. Your first definition is a point, which can be represented by a dot. And the sketch to the right is a picture of point P. Each point should be labeled with a letter. A line is represented by a line with two arrowheads written as line AB. Notice the arrows on both sides. A plane is represented by a shape that looks like a floor or wall. You need at least 3 points to name a plane. However, if you look at the plane in the example, this plane can also be called plane M. M is not a point, it could be the name to represent the plane. Also, going back up to here to line, the arrowheads mean that these lines go on forever in both directions. Collinear points are points that lie on the same line. For example, A and B are collinear points because they lie on the same line. Coplanar points are points that lie in the same plane. Here's your plane, and A, B, and C all lie within the plane. So A, B, and C would be coplanar points. A line segment has two endpoints, and the line stops at each endpoint. It can be written as AB or BA. Notice the segment does not have arrowheads on the ends because the line segments stop at each endpoint. A ray has one endpoint and goes on forever in the other direction. Notice point A is the endpoint, and going out towards point B, this line goes on forever. This can only be written as AB. As an array, the endpoint is always the first letter mentioned. Opposite rays are two rays that share an endpoint but go in opposite directions. In this example, ray AB and AC are opposite rays. They both start at A, but they go in opposite directions. Going down to example 1, we're looking at the picture on the right. A asks us to name 4 points that are coplanar. So remember, in order for it to be coplanar, they have to lie within the same plane. So the 4 points that could be mentioned are J, G, L, and K. And it doesn't necessarily have to be in that order. B says name 3 points that are collinear. Remember, collinear means they lie on the same line. So in this case, it would be J, G, K. The distance between points A and B is the absolute value of the distance of the coordinates. The absolute value of the difference of the coordinates. Let's look at some examples. Example 2 says the distance from Asheville to Berkeley is 3 miles. If John walks from Asheville to Berkeley and Sarah walks from Berkeley to Asheville, how far did each of them walk? Well, if it's 3 miles from Asheville to Berkeley, no matter which way you're walking, it's still going to be 3 miles. So both of them walked 3 miles. Example 3 says find the distance between the 2 points given. Notice our number line here goes up by ones. So the distance from 2 to 6 is going to be 4. Another handy way to find distance is if you take the larger number, which in this case is 6, and subtract it from the smaller number, which is 2, you get the same answer, 4. This will come in more handy in example B, as this time if you notice each dash is represented by 5. So 5, 10, 15, 20, 25, 30, 35, we're not going up by 1s, we're going up by 5s. So the distance from 15 to 25 is going to be 10. Or if you did the subtraction method, you would do 25 minus 15 and you still get 10. Either way works. In example C, it's a little bit tougher to calculate. If you realize, well, this one we're going up by 4s. We're going from 3 all the way up to 27. Okay, so you could either go 4, 8, 12, 16, 20, 24, or you could do 27 minus 3, which also gives you 24. Either way works. You just have to pay attention to how far each dash is going. Down at the bottom, we're doing what's called segment addition. And basically what segment addition means is we're looking at this example at the top middle here. AB plus BC is going to equal AC. So we're adding the two smaller segments to equal the big segment. Example 4 says Hillary drives from Charlotte to Duxbury, which is 25 miles. Then she drives from Duxbury to Edmonton, which is 17 miles. So how far did she drive altogether? Well, if we look at this example, from Charlotte to Duxbury is 25, so from here to here is 25 miles, and the rest of the way from Duxbury to Edmonton is 17 miles. So in order to find her total distance, we add 25 and 17, which gives us 42 miles. So Hillary drove 42 miles. Example 5, Sam is going from Washington, D.C. to Chicago. The two cities are 701 miles apart. If Sam has already driven 463 miles, how much farther does he have to go? So in this example, it's a little bit different. This example says he started in D.C., which is here, and he's gone 463 of the 701 miles it takes to get to Chicago. So in order to figure this one out, we would take 701, which is the total distance, and subtract the distance he's already traveled. So we would do 701 minus 463, which gives us 238. Example 6 wants us to find PQ. So we're going to use the same thing we just talked about in example 5 for examples 6 and 7. So from O to Q is 29, and from O to P is 8. So in order to find this missing length of PQ, we subtract 29 minus 8, and we get 21. Same thing for example 7. FH is 36, FG is 21, so in order to find GH, the missing part, we take 36, subtract 21, and we end up with 15. Example 8 wants you to find the indicated length. So there's two parts to this. In order to find the indicated length, first we have to find x. In order to find x, we're adding TV and VW, and it's equal to 32. So 3x plus 8 equals 32. Now we have to solve for x. We combine like terms, 3x plus 8 equals 32. So we have 4x plus 8 equals 32. Subtract the 8, 4x equals 24, and finally we have x equals 6. Now that we have x equals 6, we're not done. Now we take x, which we found was 6, and we plug it back into the original problem. So it says find VW. So VW is from here to here. So instead of x, we're going to plug in 6. So we're going to do 6 plus 8, which in total is going to give us 14. So VW is 14. We're doing the same thing for example 9. Find YZ. So we have to add XY and YZ together to find the value of x. So 2x plus 3 plus 3x plus 1, 3x minus 1 equals 27. Combine like terms, we have 5x plus 2 equals 27. Subtract 2 from both sides, we get 5x equals 25. And finally, x equals 5. Now again, this is not the final solution. It wants us to find YZ. In order to find yz, we have to plug 5 back into the original problem. So we do 3 times 5 minus 1, which gives us 14. So yz in total is going to be 14.